Welcome to this section, Validate the Cluster. In this section, we learned about HDFS concepts, HDFS data movement, HDFS admin commands, MapReduce jobs, and Spark jobs. Welcome to our section on HDFS concepts. We will be looking at some of the fundamentals of HDFS, and we will also talk about some of the common concepts like replication, block location, block size, and we will see practically on the system how we can change these values and what impact they have on a file or a directory. So first of all, HDFS blocks. So whenever we write any data, or let's say I copy a file to HDFS, that file will be split into multiple blocks. So by default in Hadoop 2, the HDFS block split is 128 MB. So it means that the block size is 128 MB, right? In HDFS, Hadoop 2. In Hadoop 1, it used to be 64 MB. It's a configurable parameter. We will see that how we configure that. But by default, it is 128 MB. Avoid creating too many small files, right? As it will put pressure on the name node in terms of memory. More files a name node has to maintain, larger will be the metadata. And as we have seen in our previous section, name nodes, the entire metadata in the memory. So a name node will have more pressure on the memory. So during a write operations, the blocks are streamed using data streaming protocol to all nodes in the replication chain. What is the important thing to keep in mind here is, let's say I have a file whose size is 1 MB and I'm trying to copy that file to HDFS. It does not mean that the client will copy 1 MB into 3 MB of data because replication is 3. Client will just send 1 MB of data. It is the data nodes which are actually making multiple copies of that. And there's a concept of pipeline. So the data will be copied on all nodes approximately at the same time. So it's not that the data will go to first node, it will be copied there and then to the second node and third node. It's not like that. It's similar to a kind of a continuous pipe in which your data will flow continuously to all the nodes almost at the same time. Name node returns the block location order by distance from the client. So important thing to keep in mind is, let's say you are asking for a file, the name node will return the location of the blocks for that particular file in the order of its distance from the client. So let's say if a block is on a node which is very near to the client, so that will be in the first order in the array. This way it can reduce the latency. So this is an example. Let's say I have a file. That file will be split into 3 blocks. So for example, let's say my file size is 500 MB and my default block size is 128 MB. So it will make 3 blocks, one of 128 MB, second of 128 MB, and the remaining up here, right? But the largest block size will be 128 MB, right? So it will have 4 blocks in the case of 500 MB, but I'm just giving you an example. Let's say my file is 300 MB. So in that case, 300 MB means the first block 128 MB, second block 128 MB, and the third block only 44 MB left for the second block or for the third block. So this is how your blocks will be. Let's say I have a block 1, block 2, block 3, block 4, block 5. So this is a file which is split into multiple blocks. And now let's look at the replication concept. So each block by default replication is 3. So let's say block 1 goes on data node 1. So you will not see another copy of block 1 on the same node, irrespective of how many data disks this data node has or how big the storage on this data node is. So if block 1 goes here, block 2, second copy will go on another node, third copy will go on another node. Similarly for any other block. So important thing to keep in mind that not more than 1 copy of block will exist on a data node, irrespective of the number of disks on a data node. So the default replication is 3 and the parameter which defines the default replication is dfs.replication. So it's set to 3 by default, but I can configure it. So in production, good to have replication 1 on temp directory because temp directory is something which is storing your temporary files. I can use the setrep command to change the replication on a file or a directory. I can change replication while doing a copy operation as well, which we will see. Another very important factor to keep in mind is replication is decided by the client. Many people think that replication is decided by name node. No. Wherever you do the copy operation from or the upload of file operation from, whatever is the parameter, DFS replication or DFS block size on that node, it will define the replication and the size. So for example, the block size is defined by dfs.block size. So the file Block size should be minimum 128 MB for good performance. Otherwise, if I have too small blocks, I will be creating too many entries in the name node metadata. Let's look into that on the system. So let me just connect to one of the nodes in the cluster. So first of all, let's see what is my default block size. But before that, let's go to the config directory. I'm moving to the directory where we have done our configuration of Hadoop. I will open the file vi HDFS-site. So if you look at this file, nowhere we have mentioned what is my replication or what is my block size. But still, that will be coming from the default config files. So there will be HDFS-default, core-default, which are bundled as part of the jars. So all these values are coming from there. For example, if I do, so I am trying to fetch a value of, let's say, replication, right? So you can see the replication is 3. But if you look in the config file, as I showed you, nowhere we have defined this value. Similarly for block size. So this is 128 MB. This number is given in bytes. So I can define these values in the config file if I'm not happy with the default values. So let me first of all show you how this value is affecting. So let's say I go back. I have a file here. Let's say a test file. I will do Hadoop fs-put test file. I'm copying this file to HDFS. So let's look what is the replication of this file. So how I can check? I can do, forget about this command. We will look in more details when we come to the file system health check. But what it is currently telling me, see, number of data nodes, number of racks, it is telling me this file has 1 block and replication is 3. Default replication factor is 3. So now let's delete this file. I will delete this file. And now I want to change this replication from 3 to something else at a file level. So let's say instead of having a replication 3, I want, let's say the replication should be 1. While executing the copy command, I'm saying replication is equal to 1. So now let's execute the command again. So now you see replication is 1. I can change at the file level, I can change at the directory level, the replication, rather than the global replication. So the warning which you see, it's actually saying this Hadoop command is deprecated and it will be removed in future versions. So I can use HDFS, so it will not give me that warning. Okay. So now let's look at how we change this configuration. So vi HDFS-site, either I can change while at a file level or I can change any parameter globally. So let's say I want to change this parameter. So what I will do, I will define a replication parameter here, 1. And let's say I want to change the block size also. I can change the block size at the file level as well. While how we change the replication at the file level, while doing a copy operation, I can say dfs.block-size to be whatever I want. Let's say 256. So I will change that value. So let's calculate what is the 256 value. So let me just copy this number, which is 128 MB. Let's say we will make the block size 256. So I will say echo this number multiplied by 2 because 256 block, and I'm passing to the calculator BC. So I take this. So this is 256. So I open my config file and let's modify this value here. So now replication is 1, the block size is 256. But important point which I wanted to show you, let me just quickly start the DFS. We have made this change only on the node NN1, not anywhere else. So if I do a copy operation from this sitting on this node, it will be applicable only for those files which are copied from this node. Right? So let me just quickly do a start here. Let me show you what I mean. All other nodes still have replication 3. Although I have changed it on the name node. So I'm sitting on name node. So important thing to keep in mind is name node is not which is deciding the replication. Whichever node I do the operation from, that becomes the client and that is defining my parameters. So let's say I go back. Let's create a file. Vi new. This is a test file. I save this file and I say Hadoop fs and I say put new onto Hadoop. Now let's check details of this. See, the replication is coming 1. But now let's go to another node in the cluster. Here we have not modified anything. So let me show you. We have not modified anything on this system. It is at default replication 3. So let me create a file vi new from dn1, just to identify. This is from dn1. Let's copy it. Let's check what happened to the replication factor for this file. Files -blocks. So there is an S. Remember that, files block. See, replication is 3. So you have to make your configuration consistent, or you can change the replication while copying the file. So what about the replication of the existing file? For example, let's say I have already copied this file new dn1 to the system and it's showing me replication 3. So how can I change the replication of an existing file? So what I can do is simply I can do a set rep on that. I can do set rep, I can do 1. So it will change the replication of that file to 1. I can change the replication of a directory as well. Let's say temp directory. I can change that recursively. So what I'm doing is I'm changing the replication recursively of that directory. So whenever any file is copied inside that, now it will have replication 1. So the difference between set rep, let's say in my case, the cluster is not loaded. It's a very small cluster and there's not much load. So the moment I do set rep 1, you might see that replication has come back for 1 as 1, right? But in busy clusters, it will take very long time, because set rep, actually what this command is telling, it is just updating the name node saying the replication of a particular file should be this much. But at the backend, name node will take some time whenever the heartbeats come from data node, and it will kind of schedule it. But if something is very urgent for me, I can give the W option. So what does it mean? It will not, this command will not return till the replication is met. So this is kind of an blocking option. So now you can see it is waiting for the replication to be set. It will confirm once the replication is 1, then only it will return. In the first case, what it had done, it has just asked the name node. Name node has updated its metadata. Okay, my replication would be 1, and it will wait for the block reports to come, and it will then fire delete command for the over replicated blocks. But it is not confirming at that very moment. But if I say -w, it is waiting for that action to be completed, but it will take time. So this is what we see. We can change the block size as well. I can set replication and block size per file. So if there are multiple disks on a data node, the blocks are stored in a round robin fashion so that all disks get filled at the same time. So let's say I have a data node, one disk is of, let's say 2 terabyte, other disk is of 4 terabyte. So it does not mean that 2 terabyte disk get filled first. It will do a round robin. So it will put 2 blocks or twice the number of blocks in the disk which is 4 terabyte, twice the capacity. So this is what we have already seen. So there are a lot of options to that. We will see in the upcoming sessions on FSCK. To summarize, we checked on HDFS replication, HDFS block, its location, where it stores file, and also HDFS block size. So when I say location of files, if you remember, this is what I'm referring to. So it is telling if I pass the location command also to this, let me just scroll the screen up. So it will tell me the data node where it is, right? See, it is telling me this is at this data node and this disk ID in that data node, if I give the location command to that.